very good morning, my dear students. Welcome to this chemistry digital class. As you know that yesterday we have started our chapter polymer. That is chapter number 15. In this chapter, dear student, we are talking about all those articles or things which we are using in our day-to-day life, which is made up of some part. Okay, so the meaning of polymer, yesterday we discussed the meaning of polymer. The word came from Greek word in which poly mean many and mer mean unit or part. So these are the compound of high molecular mass with carrying 10 raised power 3 to 10 raised power 7 unit, which is formed by the combination of large number of small molecule. It is formed by the combination of large number of small molecule. As polymer are very large molecule, it is because of its big size, it is also called macromolecule. The small molecules which constitute the repeating structure unit is a polymer. That small molecule or smallest unit is called monomer unit. These are linked to each other by covalent bond, and the process of formation of polymer from respective monomer is called polymerization. Okay, so yesterday we have done in this particular chapter, we are talking classification of polymer. So yesterday we did classification of polymer, and hope so you also revised at home, and now there is no confusion related to how we have classified the polymer. Now second is types of polymerization reaction that we are going to do today. So today's topic is types of polymerization reaction. If we will discuss the types of polymerization reaction, dear student, there are broadly two types of polymerization reaction that we have already done yesterday also. That is one addition polymerization, and second is condensation polymerization, which is based on the mode of operation. A third type known as co-polymerization, which has been also discussed here, which involve polymerization reaction between two different monomer and proceeding through either addition or condensation mode. Okay, basically we have two type of polymerization. Number one, addition, as name represented by adding polymer, and second is condensation polymerization. But there is one more third, co-polymerization, but this co-polymerization is the polymerization reaction between two different monomer which proceeding through either addition or condensation. So now one by one we will discuss. First, our target is to understand addition or chain growth polymerization. When same or different monomer molecules like unsaturated compound, alkene, alkadiene or their derivatives successively add together on a large scale to form polymer, this type of polymerization is known as chain growth polymerization. It means that one chain is already plus second chain plus third chain. So when these chain are going to be added, and it will form a large chain, that kind of chain growth polymerization is called addition polymerization. Due to this successive addition, there is an increase in the chain length or chain growth. It can take place due to the formation of either free radical or ionic species. Now free radical mechanism is what? These are alkene, diene and their derivatives which are polymerized in the presence of free radical generator, that is initiator, which like acetyl peroxide, benzoyl peroxide, tertiary butyl peroxide, etc. Polymerization of ethane to polymethane consists on heating or exposing of light. Mixture of ethene with a small amount of benzoyl peroxide will give free radical which start the reaction. So process is basically mechanized into three steps. The step one is chain initiative step. Name is itself explaining chain initiative step. What does it mean? It means that somewhere the chain will be initiate. Firstly, the phenyl radical is formed by homolytic cleavage of benzoyl peroxide, then phenyl radical added to the double bonded of ethene molecule. Once again, first suppose this benzoyl peroxide C6H5 C double bond O O C double bond O C6H5. This is benzoyl peroxide which will break from this oxygen and oxygen, and which once break to oxygen will have free radical. Okay, and this free radical will give us phenyl radical when we will remove this bond from here. Now here also they will form like this way. In this way, in this molecule, this free radical is going to be form a bond, that is carbon dioxide, and this C6H5 will have free radical. Now this free radical will react with ethene. This phenyl radical will react with ethene, will convert into large free radical. You can see a C6H5. Now this somewhere this will move, and here we will get free radical. This free radical will form bond, this forming bond, and one free radical will form on this. So in this way the free radical will keep on changing from one molecule to another molecule. That step is called chain initiative step. Chain initiative step. You can see from benzoyl peroxide we get phenyl radical, from phenyl radical we got large free radical. Now second step is chain propagating step. कितना लंबा ये chain जो वो ऐसे ही चलता रहेगा. The new large free radical thus formed in the chain initiative step reacts with another molecule of ethene, which to form further large size radicals. Thus the repetition of this sequence with new and bigger radicals tends to carry the reaction forward. Like if we will talk about from here, this will react with further ethene, then again it will form a large, then this will further react with ethene. So now this process will going on so long. Okay, that's why N is written here, propagation. Now when it will end somewhere when the chain terminating step. Ultimately the growth of free radical chain may get terminated by reacting with consume these free radical by combining them in different form. Like this is the one propagative, this is second propagative reaction. When these two reaction will combine, somewhere CH2 will form bond and the chain will be terminated. Okay, so these are the three steps, dear students. Step 1 is chain initiative step, number 2 is chain propagative step, and number 3 chain terminating step. Okay, in this way addition reaction will be carry forward. There are some reactions, yes, some compound, some addition polymers which form, which prepare with the help of this addition reaction. So these are polyethene. Polyethene are the simplest one. This is addition polymer of ethene. Two type of polyethene are there: low density polyethene, high density polyethene. Yesterday I explained it in my live class. Low density polyethene is written LDP. It is obtained by the polymerization of ethene under high pressure of 1000 to 2000 atmosphere at a temperature of 350 to 570 Kelvin. Low density polyethene obtained through the free radical addition and H atom abstract has highly branched structure. It is chemically inert and tough but flexible and poor conductor of electricity. So this is the ethene, polyethene. Its uses are: it is insulation of electricity carrying wires, it is used to manufacture squeeze bottle, which is mineral water, toys, and flexible pipes. With high density polyethene, it is formed when addition polymerization of it takes place in hydrocarbon solvent in the presence of catalyst like trimethyl ammonium and titanium tetrachloride, which is called Ziegler-Natta catalyst. Dear student, Ziegler-Natta catalyst is used to prepare high density polyethene. It is takes place in the hydrocarbon solvent in the presence of catalyst like triethyl ammonium, C2H5. The formula is C2H5 trimethyl ammonium, triethyl ammonium plus titanium tetrachloride. These two, combination of these two catalyst is called Ziegler-Natta catalyst at about 330 to 343 Kelvin and under a pressure of 6 to 7. It is a linear molecule at high density. Due to close packing, it is also chemically inert and more tough and hard. The preparation of this is also same, only this is change here. In place of these Kelvin, that 1000 to 2000 atmosphere, 6 to 7 atmosphere is there, and Ziegler-Natta catalyst is there. It is used to manufacture bucket, pipe, dustbin, and bottles. Ziegler-Natta of Imperia and Carl Ziegler of Germany. It was awarded in Nobel Prize of Chemistry in 1963 for development of Ziegler-Natta catalyst. That's why the name is Ziegler and Natta. Now similar way, PTFE second, which is called Teflon, polytetrafluoroethene. This is the second type of polymer after polyethene, which can be prepared by addition reaction. Its monomer unit is tetrafluoroethene molecule. It is prepared by heating tetrafluoroethylene at high temperature. So you can see CF2 double bond CF2. It will react with NH in the presence of ammonium, diammonium, ammonium peroxosulfate catalyst, ammonium peroxysulfate complex, which will convert into Teflon. So you can see it is like ethene. In ethene there was a CH2 double bond CH2. In tetrafluoroethene there is CF2 double bond CF2. It is used to make oil seal, gasket, surface of utensil are coated with Teflon to make them non-sticky. So in non-sticky whatever appliances utensils you have nowadays, that is made up of Teflon. Next is pan. It is called acrylic and orlon also. Polyacrylonitrile. It is acrylic. It is found in the addition of polymerization of acrylonitrile in the presence of peroxide catalyst. Formalize CH2. Dear student, in ethene there is CH2, but here in place of one H there is Cn. So that's why it is called polyacrylonitrile. Nitrile is there. And double bond will change into single bond. That will be, it is hard, horny and high melting material. It is used as a substituent for wool in manufacturing commercial fiber, which is named as orlon, which is used for making cloths, carpet and blanket. It is alternate of wool. These are the three compound of addition. Similar way we will see some compound of condensation step. Condensation or step growth. It is involved in the repeating condensation reaction between two bifunctional monomer. Some simple molecule like water, alcohol are lost in this polycondensation reaction, and high molecular mass condensation polymer are formed. Since the product of each step is again bifunctional and it is important, and the sequence of condensation goes on, this process is completely in stepwise manner. So hence, these are called step growth polymerization. Terylene, nylon 6,6, nylon 6, phenol, formaldehyde polymers and melamine formaldehyde polymers are some example. We will take one example to form Dacron or terylene. It is also fabric. Ethylene glycol, CH2OH. CH2OH. That is the ethylene glycol. Ethane 1,2-diol will react with tetraphthalic acid. Benzene is in center and both side oxalic acid. That's why it is phthalic acid. Tetraphthalic acid, benzene 1,4-dicarboxylic acid, will react with ethylene glycol. It will somewhere connect with CH2O. This from here it will remove H2O. Okay, and when it will remove H2O, rest is same, O, CH2, O. Now that H and H2O will remove from here, it will react from this point, C double bond O, and it will form a Dacron. Now some important condensation polymer, dear student. This is your home assignment. You will write the preparation and you will learn the preparation. Similar way, the way I told you polythene, Teflon and Erlon. You will do polyamide, nylon. This is the nylon. You take screenshot of this, although I will send it in PDF. Okay, nylon 6-10, 6, nylon 6, one is nylon 6,6, second is nylon 6,10, third is nylon 6. So there is some difference in this number. Then we have polyester. Polyester is also condensation polymer. Then we have glyptal or alkyl resin or bakelite. In bakelite there is Noblock and bakelite and melamine. Okay, so these are the some important addition and condensation. Third type is copolymerization. In copolymerization we are going to as I said, two different monomer, more than one type of monomer species will be allowed to polymerize. Here suppose styrene and 1,3-butadiene. Yesterday I told this example, and this is forming BuNaS. This is the copolymerization because two different monomer is polymerized in the form of addition or in the form of condensation. Here also free radical mechanism of polymerization of styrene is given by showing the free radical. Okay, and this is the process which goes on polystyrene. So all these things I am going to send you today. So this is all about for today because I don't want to make this video too long. Okay, so try to go through yourself. This is very simple. You need to see, although these structures are looking very big, it is looking very complex, but once you will see from which point it is connecting, so you will see this is a repeating unit. once you know the how to draw this, the same thing you will draw like this, you will draw in the same way all, and you will connect it with each other, you will combine it with each other. Okay, so that's it all from my side. Hope so you are enjoying nowadays, and you are studying also seriously. So now, dear student, I will send these notes and PDF, and please try to make the notes and try to do self study. Thank you. Have a nice day.